The Menger sponge is a three-dimensional fractal, named after Austrian-born mathematician Carl Menger, who first described the eponymous fractal curve during his research on dimensional theory in 1926. The construction of a Menger sponge is based off of an extension of the one-dimensional point set topology of a Cantor set and the two-dimensional plane of a Sierpinski carpet, which all generally involve recursively subdividing a dimension or dimensions into thirds and removing the middle portion ad infinitum. In the Cantor ternary set, a nowhere-dense construction is created by iteratively dividing a line segment into equal thirds and removing the middle segment. Then, the remaining two lines are further divided into thirds and have the middle segments removed, and so on and so on. A similar process of finite subdivision is used to generate a Sierpinski carpet in two-dimensional space. Starting with a square, the surface is first cut into a 3x3 grid, resulting in 9 subsquares. Then, the central subsquare is removed, reducing the area by a factor of 8/9. The 8 remaining squares are next themselves divided into 9 subsquares, with the centers removed. As these steps are repeated in an infinite process, the resulting area of the carpet approaches 0. By applying a related procedure to a cube, a three-dimensional version of the Sierpinski carpet can be generated, otherwise known as a Menger sponge. Created by dividing a cube into a 3x3x3 Rubik's-like collection of 27 subcubes, and removing the 6 central subcubes from each face and the core subcube from within the center, the resulting solid is a level 1 Menger sponge. This first iteration reduces the volume by a factor of 20/27. To continue the process, the 20 remaining smaller cubes are themselves further subdivided into a 3x3x3 collection of 27 subcubes, with each of the middle 7 subcubes taken out. This second iteration results in a level 2 Menger sponge, now comprised of 400 subcubes with a total volume that is reduced by a factor of 20/27 from the previous iteration, or by a factor of 400/729 relative to the initial cube. This process may be repeated for the third, fourth, or infinitely many iterations. An interesting property of the Menger sponge is that as the construction approaches the limit of the process, the volume tends towards 0, while the surface area tends towards infinity, as each step reduces the volume by a constant factor, while also multiplying the number of subcubes and boundary faces. Another surprising property of the fractal geometry is that each of the 6 faces of the sponge are Sierpinski carpets, and that any midline or diagonal line connecting 2 corner points form Cantor set intersections. One of the best ways to further investigate or appreciate the geometry and structure of a fractal like this is to construct a model yourself. Origami, and paper folding in general, like fractals, are intuitive physical expressions of mathematical concepts like ratios, symmetry, tessellations, recursiveness, and trigonometry. The repeated identical units used in modular origami are perfect for constructing polyhedra, platonic solids, or even fractal models such as the Menger sponge, using only paper Sonobe modules or other unit assemblies. However, Menger cubes can also be constructed from business cards, blocks, friendship bracelet charms, tape, or most uniform materials that can be made to form right-angle vertices. In theoretical constructions of a Menger sponge, the process involves a subtractive step-by-step removal of square holes. But in practical real-life constructions, the easiest process is an additive one, which starts with building all of the subcubes first, and then attaching them all together to form the Menger sponge. My preferred method for construction, which I will demonstrate shortly, uses square sticky notes and Scotch tape, but is by no means the best or definitive approach to making a real-life Menger sponge. My reasoning behind this approach is mainly the low cost of the materials and the quantity and regularity of the 3" by 3" sticky notes, which can be easily torn or creased. This process will yield from each sticky note 1 subcube and a pair of connectors to join it to the other subcubes. Therefore, to construct a level 1, you would only need 20 sticky notes, and to construct a level 2, only 400 sticky notes, which is a commonly found amount in packs of 4 100-sheet pads. To begin, fold one sticky note into fourths by first folding it in half lengthwise, and then again from both edges to meet the previous fold. Next, the sticky note is folded in half in the other direction, resulting in a grid-like pattern of 8 1x2 rectangles formed by the creases. Carefully tear along these creases to produce the 8 rectangles, 2 of which will have the sticky adhesive on the back. Take these 2 and fold in the corners like this. These 2 pieces will be used later to connect this subcube to the others. With the remaining 6 rectangles, fold each into a square shape by first folding one edge near the center and then bringing the opposite edge to meet it. Once this step has been completed for the remaining 5 rectangles, you will be left with the 6 square faces of the subcube with flaps to allow them to stay together. To construct the subcube, simply build it one face at a time, ensuring that all the flaps get tucked inside of the cube. Once all the pieces are fitted together, they may need extra help getting compacted, but after this final step, the single sticky note has been turned into a cube and a pair of connectors. If this is done 20 times, then you'll have enough cubes to begin building a level 1 Minger sponge. To connect the cubes, slide one half of the connector behind the face of one subcube, and then tuck the other in behind the face of another. This will temporarily hold the cubes together before they can all be taped, and help align the faces and keep them flush and level. After the sponge has been put together, the final step is to tape all the connections, edges, and corners. Fortunately, the standard dimensional width of Scotch tape is 3/4 of an inch, which happens to be equal to the length, width, and height of each subcube. When the taping step is complete, the cube should be compositionally strong and held into shape. To construct a level 2 Minger sponge, make 19 more level 1 cubes and configure them in the same way as before, this time totaling 400 subcubes and accordingly requiring 400 sticky notes and around 4 rolls of tape. It took me about 30 hours to build this level 2 sponge, and to make a level 3 Minger sponge would require 8,000 sticky notes and take approximately 600 hours or 25 full days, so wish me luck!